Hey folks, how are y'all doing? So as Laura said, so we're going to kind of plow right in. Got a tight thing here. So we're going to plow right in. As Laura said, my name is Dan Zentgraf. I'm up out of Austin, Texas, and among the various things I do down there is I serve as an organizer to DevOpsDays Austin, and I can speak from personal experience. We just did our 8th annual event down there. I can speak from personal experience. It takes a ton of work to bring one of these things together, so be sure and thank the organizers, volunteers, and sponsors who are helping us enjoy this event today and the great environment and venue that we're in. So with that, my talk today is about the database thing, dealing with how we do DevOps in the database, and there's sort of this afterthought we have about the database. It's kind of this weird thing, right? And the funny thing about this, so as we go in, right, so we're going to talk about this. I'm going to focus primarily on relational databases, just to be clear. It's not that NoSQL databases aren't kind of their own bucket of fun, but I spend most of my time with enterprises where the vast majority of data is still in relational formats and relational platforms. I'm going to talk a little bit about the blocking factors, like why is this hard? Take a look at database change management. Maybe if we understand the problem a little bit better, we can do something about it. And lastly, look at some of the things we're going to have to deal with as we bring databases into our CI/CD flows. So, first up, to be clear, this isn't like a revolutionary problem. Database change management has kind of been around since the dawn of the database. And the CD community has known about it for years. I think there's like 3.5 pages in Jez Humble's book where it actually mentions databases. Right? It's only about that thick, 3 pages. I can speak from my own personal experience. Literally 12 years ago, we were talking about this very thing. It was still kind of like the CI days. It was before CD was really a buzzword, but we knew that when we built it, we had to deploy it somewhere so that we could run our tests. All right? And we looked at all the stuff we'd have to integrate to pull that off and bring automation to that problem. And we put the databases dead last because it just looked frickin' hard. It just blows me away that 12 years later, it's still kind of the same state of affairs. And if you think about it as a community, we've had the opportunity to DevOps the heck out of everything else, and in some cases twice. And yet, I go into these enterprises and they talk about how they're deploying their applications in minutes, maybe hours, but really fast. And the database takes hours, and in some cases days, right? We've got 72-hour SLA for that ServiceNow ticket. Yeehaw. And the tool community really hasn't done that much. Like the orchestration community, you look at the process orchestrators, the things that are classic CD tools, new ones, old ones. I did a quick survey of a mix, new ones, old ones, classics, shinies, cloud native, whatever. And 201, you look at their kind of core functionality for solving this problem, and it boils down to, we run that SQL script real good for you. Woo! And we know that just sticking scripts into like a little thing that runs them isn't quite the same as automation. So it's kind of a weird thing. So with that, I kind of was like, well, what is it about databases that really makes this such a big problem? I've been kind of focused on this now for the last little while, and there's a number of things that kind of block us from doing this, right? The first part is technical. All right, let's be clear, databases are funky, sticky, stateful things that don't lend themselves to easy automation and management. That's kind of like a design feature. You don't want them like randomly changing things. You kind of want it to stay, right? And despite the fact that they actually have one of the oldest DSLs on the planet, it's an actual international frickin' standard recognized by international frickin' standards bodies, right? Go find another DevOps tool that can claim that, right? But we don't manage them as code. We have like manual processes and handcrafting this and various rituals. It's kind of crazy. But here's the thing, right? Is that in addition to the data in the databases, the structure around the databases, there's more than just data in these databases. And if you screw up one of these other pieces, you can lose data. And that makes people very sad. All right? And additionally, the other thing that's there is structurally, databases serve as an integration point in most organizations due to the history and whatever. Monoliths, the databases are still kind of the key point of integration among a lot of our application systems, right? Whether we're monolithic or even in some cases working on getting to microservices, the databases are a point of integration. We don't have the APIs yet. So it's down deep in the stack, and if you touch it, stuff falls over and falls down. And you figure out pretty quickly that, you know, especially in a big organization, you don't just update a database schema. Second piece is, of course, the big organization factor, right? In most organizations, you find that the database team is a black box on the other side of a wall. You stuff stuff in some kind of a ticket and you toss it at them, and it's kind of their problem, right? Now, the DBAs are now seeing more and more of the changes coming at them as devs are adopting Agile and other practices. And we're getting full stack developers now that have to be empowered to make their own database changes if they're going to do their job. And the developers vastly outnumber DBAs. I mean, I've seen numbers like I typically see in these big organizations. I kind of been taking a little survey, 100 to 1. Actually, my record is 200 to 1 developers to DBAs supporting an app stack. Very big app stack, to be clear, but enterprises. You have this stuff going on. The DBAs are under a hell of a lot of pressure there, and on top of it all, they're seeing a proliferation of database platforms that used to not be enterprise, now are enterprise. They can come in and they're acceptable. Now the DBAs have to learn that, and it's just added to their workload. You don't get new DBAs, you just get new databases and new platforms. All right? And let's be clear how corporations have started looking at databases. Right? Data is super important. It is the most valuable asset our company has. It is the new oil under this new industrial revolution in which we find ourselves. So no pressure, and you wouldn't want anything to happen to that resource, DBAs. Right? And you put these things together and you figure out that, yeah, this is a really tough thing. You know, like when you bring these factors together, as ever in DevOps, right? It's technology, it's processes, it's cultures, all these things. And you figure out pretty quickly that a lot of what drives this is the fact that the penalty for failure is extremely high. Big corporations have these multi-terabyte databases, you know, 50 plus terabytes is not uncommon, and they're not getting any smaller, right? And if anything bad happens to it, it's a bad day. The time to recover one of these things is ridiculous now. And depending on the visibility of your brand, you screw this up, it's not just a bad day, you could be in the news. Right? So classic kind of big mission critical problem, and the databases are right at the root of it. It's harder to deal with. Right? So the organizations have responded, as they usually do, by throwing people and process barriers to change rather than facilitators to change. Right? Make it safe. Put an expert in the loop. Right? No matter how overworked, the expert is our safety valve, and if nothing else, we can blame them if things go wrong because they were the expert. Right? Meanwhile, you have other factors, right? If you think about what this means, if I've got all these different teams and the database is my point of integration, well, that's a lot of people injecting change into this thing. So how the heck do I control what's going on there, and how do I know my changes aren't going to break anything? All right? I got limited SQL knowledge and skills through the organization. Yeah, the full stack developers should be doing this stuff. That's awesome. How many of them have been writing SQL for any length of time or at any volume? Right, the DBAs still have to serve as kind of coaches for that stuff because it's a relatively new phenomenon, and you know people are learning. They can't, you know, they may be able to write the change, but will it be performant? Will it kill the database with some sort of an incredibly long operation? You need some way of catching that stuff, right? And on top of that, part of the reason we have that proliferation is, hey, it's a cost center, right? It's IT ops. So how do we drive that down? Well, we start changing out our databases because that open source stuff is a hell of a lot cheaper than the classic databases we called enterprise, and we are done buying Larry Ellison yachts, damn it. So it's pretty daunting when you start thinking about this, right? But I got a piece of good news for you, all right? We've done this before as a community, right? So in DevOps, we have fought this battle before. Like, yeah, I've been at this a while, so I mean, I remember back in the old days where we used to have to convince system administrators that, hey, an ephemeral environment is actually a possible thing. You don't have to hug that server, right? There was no magic bullet for convincing them to do it, right? I mean, we had to decide to do it and work them through it. right? It's kind of like we're fighting with a lot of the DevSecOps stuff today, right? There's no magic bullet for getting people to do it. It's important. It needs to be done if we're going to go forward, right? There's no magic bullet for tearing down those monoliths integrated at the database level, giving proper APIs so they can communicate. And, you know, bad news, it's engineering. There's no magic bullet for any of this stuff, right? Right? So at the end of the day, it comes down to buckling down, making sure we have a good definition of our problem and where our primary bottlenecks are, starting to build and implement some solutions, working through it, measuring our outcomes, improving, iterating, and getting better so that we can get this bottleneck out of our way. Which brings us to the next comment. What does database change management even really mean? Like, I mean, how many people have actually thought about database change management? It's just kind of running some SQL scripts, right? I mean, what are the principles in play here? So the funny thing is that, or well, I think it's kind of funny, but it's like, guys, it's actually pretty simple. There are two basic ways you approach this problem. All right? First is what we call a migration-based approach. Right? And in this approach, we say that the change is the most important thing. That is our first-class citizen. We create the change, we manage the hell out of the change, and we understand what's going on with the change itself at all points in the cycle. The second avenue is what's called state-based. And this says that the state of the database, or databases, in the pipeline as they lie, are the first-class citizen. The state is the most important thing, and we worry about finding the differences among them to figure out how we want to make and progress our changes. All right? So, summarized, migration-based is the as-code-based approach. State-based is primarily a point-and-click type approach. Migration requires the change creator to have good knowledge of the SQL language, the database engine in question, whereas in the state-based, you can rely on the tool to do that for you. All right? Change creator specifies specifically what will be changing. The tool figures it out in a state-based environment. All right? Migration-based only cares about the impacted objects. State-based cares about all the objects all the time by its nature. Each of them have strengths and weaknesses. There's a set of trade-offs. Right? It's engineering. Right? There's no magic bullet. There are good points and bad points to each of these. Right? Now, in a migration-based approach, because it's as code, we have a lot of existing doctrine for how we manage and track code. We know who wrote it. We know who checked it in. We know how to merge the code from multiple creators. I can isolate my changes very easily in a large database. I can group my changes very easily so I know what's a release, what's in the release, and what's moving forward. And if I have a bunch of data refactoring going on in there, it just plugs right in. Pretty cool. Now, state-based, on the other hand, is really good when it comes to closed teams. If I got a single app, single database type situation, it's very easy to isolate stuff. I don't have to worry as much about having somebody on staff who's a good SQL and database person, or make sure that I've got that knowledge widespread. I can get a built-in drift detection, so if somebody starts monkeying with the database anywhere along that pipeline, I'm going to see it because I'm looking at it all the time. And it's really easy to deal with bulk changes. Right? If I make a whole bunch of changes someplace and want to just know what the hell happened, boom, I'm in and done. All right? Now, conversely, each of them has a series of downsides. All right? Migration-based, it has the core problem that there is a need for strong database engine and SQL knowledge someplace on the team, and I have to use that knowledge to intelligently sequence my changes so they actually work. Remember, database changes have to go in a certain order, otherwise, well, bad things can happen. Right? We're going to have to do the DevOps thing and tear down some of our organizational walls. Right? And I'm going to have to invent a process for that drift detection thing. So if I'm in a large environment where there's a lot of stuff coming in, I'm going to have something that monitors for change. All right? State-based stuffers, as you get into larger complicated environments, and you have this situation where you need to isolate and merge changes from multiple contributors. It becomes very difficult to do that because whose state takes precedent? Well, it works on my machine, 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 and there's the database in the middle. Who goes first? You have to answer that question, and you have to invent a process to arbitrate the changes as they come in and come together. Right? So you're inventing a kind of a process either way. All right? State-based also requires you to be absolutely sure of the state before you push the button to generate the changes. All right? You have to do it absolutely perfectly every time, or you could end up promoting different stuff between different stages in your environment, and that's not traceable. So that's a thing. Right? And if you do the bulk thing, somebody gets to review review the code. And if you've ever reviewed code generated by a tool, you know how much fun that really isn't. All right? So the cool thing is that if you think about it, you're going to end up using attributes of both of these. You're going to pick one as your primary. It's going to be your organizational doctrine for how you do this. But there's no like purity thing here. This is engineering. You use the capabilities at hand. You take a primary approach that you can build your processes around, and you cherry pick the stuff that's going to help you. So if you're doing state-based, you still are probably going to need and want to add tweak scripts. That doesn't mean you're suddenly going migration-based. It just means you need some tweak scripts. Similarly, you might use a state-based technique to make sure that you're writing the best changes possible in a migration-based approach. All right? Doesn't mean you're suddenly state-based. All right? Okay, so database changes, got kind of an idea of what's going on there, still doesn't answer the question of, well, how do we actually break the bottleneck? How do we bring these into our CI/CD processes? Again, the good news here is that we've learned some things over the years. Let's just put some example principles of CI/CD, not a comprehensive list, just some examples of things you need to do to pull off CI/CD for anything, full stop, all right? We need to involve everyone. Seems like it's always a good idea, right? It's a DevOps is collaboration kind of a thing, right? I need to figure out how to do fast feedback loops. If I'm going to make a change to something like an app or a database, I need to know whether that change was any good. Did it do what I wanted? Does it actually advance the ball for my application, right? How do I have small batch processing? How do I keep the changes small so they're easy to track and troubleshoot, right? How do I make sure that I'm doing things the right way everywhere I go? Right? Do it the same way all the way through the process. My environments all look the same. Everything is consistent. Again, guess what? Totally applies to databases. So when we talk about focusing in on bringing the databases into our CI/CD flow, let's talk about it in 4 angles. All right? First, we want to version everything. We want to automate everything. We want to test everything. And that production-like environment stuff for a stateful beast like a database becomes super flippin' important. All right? So, versioning everything. The one thing I love about these things is we have these vast pithy things in the DevOps movement, right? Version all the things. What are all the things when we start talking about database changes? What is everything in our context? Well, first is the changes themselves. Right, is like check your SQL scripts into source code, please, for the love of God. I mean, you know, and that sounds obvious. It's like, oh, well, we do that. And it's like, you'd be shocked at the number of these large enterprises that I go into. And I go in there and you find out, and this just happened last month, large financial services company, someplace on the West Coast, tons of PII, massive, you know, financial regulated space, SQL changes in an open file share. Yeah, that's a thing. So yeah, anyway, start there. The second thing that you have to think about when you're versioning stuff is how do I group my changes? If I'm going to actually make multiple changes into a system, how do I group them and version that group so I can track it through my pipeline? These changes, I've tested them n number of times, these changes in this order all together. And how do I do that in every environment? Consistent, so I can be repeatable. Third thing is the schema itself. I need the schema to be able to self-identify both to a human as well as to the automated process where it's at. So I know what schema I'm working on. I can compare, I can contrast, I can run my changes, and I can know if these changes are actually a fit or not. I can do some determination of am I doing the right thing in the right place. Whether it's as a human or as an automated process, without that instrumentation, problems occur. All right? Second thing, automate everything. Automation is the backbone of everything we do in DevOps. All right? Absolute backbone. And when you apply that to bringing something like database changes into the CI/CD pipeline, we have multiple points we have to think about. The first is, how do we actually apply some automation to the inbound changes to screen them? How do we shift left some quality here, right? Like we've got builds for code. How do we get something like that for our database changes and give feedback immediately to the change creator that, hey, these changes are great. Hey, these changes kind of suck, right? I mean, this is like the very first thing that we need to determine, right? How do we break the build over a bad database change, right? It seems like a simple question. We do it for everything else, but there you are, right? Obviously, we want to be automating through the entire pipeline. We want to do the same thing in every environment, every time. We want to do it the same way so that we know that it's repeatable. We know that it's an actual rehearsal for production. I want to do it a lot of times in my lower environments. Stop me if you've heard this one before. We want to rehearse our deployments in lower environments so when we get to production, it's a non-issue. That way we know it's repeatable. That way when we do it, we have a high degree of faith that we're going to get what we expect. All right? And the last thing is, how do I use automation smart so that I can refresh my environments? Right? If I'm going to automate going left to right, so your left to my right, or yeah, your left to your right, anyway, that way. We also have to worry about coming back the other way. See, I even made it like from your perspective. That was hard. Anyway, the idea is that you can use automation to refresh the environments. The only way you're going to get these big environments refreshed and know that you're testing in good environments with good test data, so you have high fidelity tests as you go through, is with deliberate and diligent application of automation to that situation. I refresh my database to this point, add my changes to support the feature changes that are going, run the tests, reset as quick as I can. All right? Not going to happen with someone typing fix scripts or copying them in from ServiceNow. All right? Testing everything. Okay. So I mentioned already the idea of having a good set of inspections for the changes at the build time. Right? We're trying to answer 3 questions when the changes come in. Right? Are these changes valid and good? Right? I've got static code analysis for my app code. Guess what? Static code checkers exist for SQL. Right? You can use them. Right? They work. And you can know if these changes are even acceptable. Like, should I do anything with them in the first place? Then I need to know, do they work? And if they do work, do they leave the database in a good state? Right? I mean, I know if my code compiles and I can run smoke tests against it, how am I inspecting my database changes? How am I making sure that they work, or that they worked the way I expected? All right? Right? At any stage in the pipeline. And what's my strategy for fixing it? Right? Can I refresh the environment quickly? Do I have some kind of a fix script that goes with it? Do I roll back? Do I fix forward? What is it? You have to pick. Otherwise, you spend a bunch of time with people sitting on their hands while somebody fixes the database so that you can do it again. And remember that by definition, at some point here, you are putting completely untested changes into a target database. Things are going to break. You have to have a strategy for resetting that environment and trying the changes again to when they will hopefully work. And that goes directly to this idea of ensuring production-like environments. I mentioned this before, right? You have to figure out what your refresh strategy is going to be. How do I refresh that environment quickly? There's techniques for doing it. There's bespoke tools. There are things in the cloud. There are things in your SANs, if you're on-prem, that you can do to rapidly reset a database, right? Not just the structure, but also the data in it. And there's test data management products that you can create your own hybrids of different techniques to do it, right? Again, you have to have a strategy. Otherwise, what the heck are you testing against? Right? I mean, legitimately, does it have the right schema for the feature you're testing? Does it have the right data? What? Right? But you can deploy that app code and test it real quick. Right? Really? Okay. So this becomes a thing, right? I mean, you can do simple things, right? Like, clever thing I saw recently is kind of like test-driven development, right? Your pull request doesn't get accepted. It's kind of like, you know, your pull request doesn't get accepted if you don't have the matching test for the new inbound feature, right? Your pull requests for your SQL changes don't get accepted until you have the matching fix script. Whether it's rollback or fix forward, we don't care. We picked a strategy. It just doesn't get accepted, full stop. All right? Simple things, simple steps, measurable improvements. And that's really where I want to wrap up, right? Is the database changes that in our environments and our application chains don't have to be slow, right? There's no reason for it. The tools, the techniques are out there and they work, right? It is completely doable, but there is no magic bullet. So I hope you take away from here the ideas and stuff to get started and bring this stuff and start working on it in your own shop and take this bottleneck out of your environment, take the quality problems that go with it out of your environment and start making it work right. To that end, I have a number of resources you can look into, some reading on database change management. I will post these slides someplace. The organizers here said something, there will be a place to put them. I will put them there. So there's readings and some tools, both open source and commercial, that can help you do the things and learn about doing the things here for your inspection. So with that, I think we're right at about time. And we're going out into a break. I'm standing between you and coffee. So I will be out there someplace and we can chat and do questions in that scenario. And I want to thank you all very much for coming out.